The Hobart-class destroyers are the centrepiece of the Royal Australian Navy's surface fleet, acting as the foundation of task force operations. Although called air warfare destroyers by the ADF, the Hobart-class are highly capable general-purpose warships, as effective in anti-submarine warfare as they are in air defence. In fact, they are the most capable major surface combatants the RAN has ever operated. However, the air warfare destroyer program was deeply troubled, and although the vessels that are now operational are more than meeting expectations, their construction revealed just how dysfunctional the Australian naval shipbuilding industry was. In fact, one could argue that it was in the trials and tribulations of the Hobart-class's birth where the most valuable lessons were learned, and it was in direct response to the failures of the program that the foundations of a sustainable future naval industry were built. Even more than their services warships, this may be the greatest gift these vessels have endowed to the ADF and the Australian people. In 1999, HMAS Perth began her decommissioning, and by the year 2000 her two sister ships, Hobart and Brisbane, were also struck from the Navy's order of battle. The Australian version of the American Charles F. Adams class, the 4,000-ton Perth-class destroyers had served the RAN from the mid-1960s, providing a dedicated wide-area air defence capability for task force operations. With their retirement, the role of area air defence fell on the 6 Adelaide-class guided missile frigates. Although only frigates, the Adelaides were highly capable warships. Based on the Oliver Hazard Perry class, the Adelaides provided a comparable air defence capability to the Perth-class destroyers through their 40 missile magazine and ability to deploy the SM-1 surface-to-air missile. However, with the decommissioning of the Perth class, the ADF realised they needed a far more capable replacement for the Adelaide-class frigates, one that would truly serve the role the Perth class had for so many decades. A vessel that would provide the RAN with very capable air defence for the majority of the first half of the 21st century. The capability requirement was first outlined in the 2000 Defence White Paper, and by May 2005, the air warfare destroyer program had officially begun. There were two primary contenders for the air warfare destroyer contract: Navantia, with a version of the Spanish Navy's F-100 frigate, and the US shipbuilder Gibbs & Cox, who proposed an evolved version of the Flight II Arleigh Burke destroyer. Throughout the early design process, both the Department of Defense and the Navy declared that the American design was the preferred option. However, both tenders required further revision. Although a scaled-down version of the Arleigh Burke, fielding only 64 vertical launch cells as opposed to the typical 96, the Gibbs & Cox design was substantially larger than the Spanish alternative, displacing an additional 2,000 tons and having increased manning levels. In spite of the aggressive lobbying by Gibbs & Cox and public statements made by the Chief of Navy, in 2007 the National Security Committee announced that the Spanish option had been selected. This decision came as quite a surprise to many in both the Australian strategic community and the general public, as the selection seemed to be a foregone conclusion. But the substantially lower risk of the F-100 design proved to be decisive. Although there were dozens of Arleigh Burkes operational, to meet Australian displacement requirements, the whole ship had to be totally redesigned, effectively making it a brand new class. The revisions to the F-100, on the other hand, were relatively minor. From the very early phase of HMAS Hobart's construction, severe manufacturing problems were revealed. Like a huge Lego project, the Hobart class were constructed in 31 large segments, called blocks, in different shipyards around the country, in addition to some that were manufactured in Spain. These large blocks, each of which weighed around 200 tons, were then shipped to the primary construction facility, the Australian Submarine Corporation in Adelaide, for final assembly where they would be welded together. The first keel block, which is one of the heaviest and most difficult to manufacture, was found to be badly warped and could not be assembled with the others. Although there were reports from the shipyard in Melbourne that they had received faulty drawings from Navantia, the problem was later found to be a fault in their manufacturing process. Because there were several different companies and shipyards manufacturing elements of the vessel, in addition to the designer, as problems developed, their relationship soon turned acrimonious. With the delivery schedule slipping and costs beginning to spiral, the different shipyards and companies began blaming each other, only slowing the process down more. By 2012, 25% of HMAS Hobart's internal piping had to be replaced due to faulty manufacture, and the ship's mast block was rejected. By 2015, the program had overrun its cost estimate by 1.2 billion Australian dollars and was running 2.5 years late. With the end of both the Anzac and Collins-class construction, Australia's shipyards had been without major programs, leading to a large-scale skills exodus. Despite its contrary assertions, the BAE shipyard in Williamstown, Victoria, where the Anzac class had been constructed, neither had the skills nor the capacity to meet the requirements of the much larger vessel, and ASC was also facing a skills shortage. Australia's shipyards were effectively strangled by the haphazard nature of the RAN's procurement, as after large-scale construction programs ended, most of the skilled workforce moved on. Additionally, the Commonwealth was generally too relaxed in its oversight of these programs, leading to an unproductive culture in some of the shipyards. In July 2015, the whole program was restructured, and the Spanish shipbuilder Navantia was effectively placed in a management position over the primary shipyard, ASC. With the injection of expertise and the restructuring of the relationships between the parties, the program immediately improved, and although the lost ground could not be made up and these vessels would be delivered 3 years late, the situation was brought under control. The 3 vessels of the Hobart class are HMAS Hobart, HMAS Brisbane, and HMAS Sydney, and all 3 ships were commissioned by 2020. There was an option for a 4th vessel, but this was not taken. HMAS Hobart is 146 metres long, 18 metres wide, and has a 7 metre draft. At full load, she displaces 7,000 tonnes. Her top speed is in excess of 28 knots, and has a routine complement of around 180 crew. Travelling at 18 knots, the Hobart class have a range of around 4,500 nautical miles. They are equipped with a single hangar and deploy an MH-60 Romeo Seahawk helicopter. Perhaps the best way to understand the Hobart class is to think of it as a miniaturized Arleigh Burke. It takes all of the core warfighting capability that Burke provides, the same combat system, the same or equivalent sensors, the same weapons, but just does it in a smaller hull which is less expensive and has substantially lower manning levels. However, with that reduced size comes reduced firepower. 48 cells compared to 96, 2 missile illuminators as opposed to 3, 1 close-in weapon system instead of 2, and just a single helicopter. Nevertheless, the core warfighting capability of the Hobart is the same. It brings the same tools to the fight, just fewer of them. Arguably the most critical combat capability the Hobart-class destroyers bring to the RAN's order of battle is the Aegis combat system. An often overlooked element of warship capability, combat systems are critical enablers, allowing the weapons, sensors, defensive systems, and decision makers to form one integrated whole. They act as the ship's central nervous system. At its first introduction in 1983, Aegis was the world's first complete battle management system, and has been through 9 generational upgrades since then, with the Hobart class fielding the baseline 7.1. The Aegis weapon system contains the following core components: the command and decision system, the weapons control system, the Aegis display system, and the trainer and testing systems. Aegis takes the information which is provided by the ship's sensors and generates a coherent picture of the battle space, automatically tracking and evaluating hundreds of surface, submerged, and airborne contacts. The system can automatically engage hostile contacts with the ship's various weapons extremely quickly. Through a technique called cooperative engagement capability, the Hobart class can share targeting information with other warships, such as the Anzac class frigate. With this networking capability, a whole RAN task force can essentially be controlled by the Hobart's battle management system, providing substantial synergistic benefits to every vessel in the network. The Hobart's primary air search sensor is the Spy-1D radar. Operating in the S-band, this extremely powerful 3-dimensional radar has a peak power output of 4 to 6 megawatts, giving the system a very long range. In fact, the Spy-1D is powerful enough that it can track satellites in low Earth orbit. The Spy-1D is a PESA, or Passive Electronically Scanned Array, radar, which electronically steers the radar beams rather than rotating the radar mechanically. This allows for extremely fast scan rates. The 4 radar panels are made up of 4,100 discrete elements and have an aperture of 3.6 meters each, and are arranged to provide continual 360-degree radar coverage. The system is capable of tracking over 100 airborne targets simultaneously. Compared to the 2-dimensional, mechanically scanned SPS-49 radar deployed on the Adelaide class, the Spy-1D is a quantum leap in capability. These vessels also deploy the Vampire Infrared Search and Track System and the SPQ-9B X-band Horizon Search Radar. For the prosecution of air targets, the Hobart fields a pair of Mark 82 missile illuminators and the Mark 99 fire control system. Although this system can only provide target illumination for 2 missiles at a time, this is only required for the last few moments before impact, so many more missiles can be in the air simultaneously. Forward of the bridge, the Hobart class are equipped with a 48-cell Mark 41 vertical launch system complex, which houses the ship's primary air defense armament. All of these cells are strike length, meaning they can accommodate large weapons such as the Tomahawk missile or LRASM. Currently, the Hobart's primary wide-area air defense missile is the 4-meter tall Standard Missile 2, or SM-2. The SM-2 Block 3 is a highly capable weapon. Its dual-thrust solid rocket motor propels the missile to speeds in excess of Mach 3, and it has a total engagement range of around 90 nautical miles, roughly 160 kilometers. Its seeker combines a semi-active radar homing element, which relies on illumination from the warship, with an infrared guidance system, providing dual-mode target prosecution. The SM-2's primary role is to shoot down airborne targets such as helicopters, aircraft, and anti-ship missiles at altitudes ranging from sea level to high altitude. The weapon also has a secondary role in striking surface targets such as small vessels. The SM-2 may be supplemented, and eventually replaced, by the SM-6, which substitutes the dual-mode semi-active radar homing seeker with the active radar homing package from an AIM-120 AMRAAM, giving the SM-6 an over-the-horizon engagement capability. The Hobart's other surface-to-air missile is the Evolved Sea Sparrow Missile, or ESSM. The same weapon which is deployed on the Anzac-class frigates, the ESSM provides an infield defense for anti-ship missiles and aircraft to a range of some 27 nautical miles or 50 kilometers. Effectively an SM-2 in miniature, with a similar semi-active radar homing seeker, the ESSM provides a comparable capability in a much smaller package. The weapon is specifically designed to counter supersonic anti-ship missiles, especially those operating at low altitude. As the ESSM is much smaller than the SM-2, 4 can be quad-packed into a single Mark 41 VLS cell, meaning some 32 weapons can be deployed in just one 8-cell VLS segment. This feature substantially increases the Hobart's potential defensive missile capacity. For example, a typical missile load may be 40 SM-2 long-range missiles supplemented by 32 ESSMs, giving the vessel some 72 missiles in total. The final elements in the Hobart's air defense system are the Phalanx close-in weapon system, housed above the helicopter hangar, and the Nulka decoy. The Phalanx is a radar-guided 20mm Gatling gun that is specifically designed to shoot down incoming anti-ship missiles. Equipped with a dedicated Ku-band fire control radar, which is supplemented by an infrared system, the 20mm Vulcan cannon has a rate of fire in excess of 4,000 rounds per minute. Finally, the vessel is protected by the Australian-designed Nulka active decoy system. Launched from the vessel, the Nulka decoy hovers some distance away from the warship and emulates its electromagnetic signature, providing a highly accurate phantom target for incoming missiles. In combination, these systems provide a truly formidable, layered air defense capability, entirely able of engaging the highest level of air threat such as MAST, supersonic, sea-skimming anti-ship missiles. Although called an air warfare destroyer, the Hobart class are actually highly capable anti-submarine warfare assets. In fact, at the time this video was published, they are the most capable ASW surface vessels the RAN possesses. The ships are fitted with an ultra-electronics integrated sonar system, which includes both a hull-mounted and towed array sonar. The hull-mounted Sea Searcher is a medium-frequency hull-mounted sonar, which provides both active and passive search and track capabilities against submerged threats. It is capable of omni or sector transmission, mine detection and avoidance, and acoustic torpedo detection, all in addition to medium-range submarine detection, track, and classification. The Sea Searcher is paired with a number of towed array systems which form a towed variable depth sonar, which is built up from a quad-directional active-passive receive array, a passive torpedo detection array, and a high-powered towed sonar source. This sonar suite is highly capable of detecting and tracking submerged contacts at very long range, and is the most advanced ASW sensor suite ever fielded by the RAN. Paired with the dipping sonar-equipped MH-60 Romeo Seahawk, the Hobart poses a deadly threat to enemy submarines. For short-range submarine engagement, the Hobart class will be equipped with the Mark 32 Mod 9 triple torpedo launcher. Currently, the MH-60R Hilo deploys the Mu-90 impact torpedo. The Hobart class is adequately equipped in the anti-surface role, with the ubiquitous 5-inch Mark 45 naval gun, which can be used for shore bombardment and close-range anti-shipping. With developments in shell technology, such as the hypervelocity projectile, the 5-inch gun may take on a critical air defense role, much like it did in World War II. In between the two exhaust funnels are a pair of quad launchers for the Harpoon Block II anti-ship missile. The Harpoon is a subsonic, sea-skimming anti-ship weapon with a range of around 127 kilometers. The Block II variant integrates the GPS and inertial navigation system from the JDAM GPS-guided bomb with the traditional radar seeker, allowing for the engagement of land targets or ships in port. Although now quite dated, the ability to volley fire 8 missiles still poses a very dangerous threat to all but the most heavily defended vessels. The Harpoon Block II may be replaced with more modern systems, such as the LRASM, in future. Finally, for defense against small vessels, the Hobart fields a pair of Rafael 25mm autocannons. As can be seen, the Hobart class are highly capable warships, not only in their designated role of air defense, but across the full spectrum of maritime warfare. They are certainly comparable to the Royal Navy's Type 45 class destroyers in aggregate capability. Some may think that because the Hobarts have half of the total VLS capacity of an Arleigh Burke, they provide half the total warfighting capability. But this is simply not the case. Hobart's ability to manage the air battle is identical, as is its capability to generate a coherent picture of the battle space. In a typical counter-air scenario, where the two vessels may have to engage 10 or 15 anti-ship missiles, the difference between them would be minor, just the third missile illuminator. The main advantage the Arleigh Burke's additional VLS capacity provides is persistence. By having twice the missile magazine space, the Burke can remain in the fight for longer. For example, the Hobart may perform just as well as a Burke for the first 2 or 3 air attacks, but would then have to retire to replenish her magazines. Moreover, the additional VLS capacity allows room for the deployment of other weapon systems, such as the Tomahawk land attack missile and ASROC rocket-assisted homing torpedo. Utilizing these weapons on the Hobart will certainly have a negative impact on their air defense capability. Nonetheless, in their primary warfighting roles, the Hobart-class vessels undeniably bring the core warfighting capability of the Arleigh Burke to battle, all at a substantially lower cost. The most critical difference is manning. The Hobarts have almost half the crewing requirement, which translates to billions of dollars of savings over the life of the vessel. This is especially critical for the RAN, which has, historically, faced manning issues. Perhaps the greatest service these vessels will provide the people of Australia, over and above their capability as truly modern and formidable warships, is the impact their troubled birth has had on Australia's naval industry. Australia is currently embarking on the greatest naval expansion in its history, and clearly intends to become, and remain, a globally significant naval power. Like all major naval powers, the Australian government has now undertaken a commitment to develop a sustainable, sovereign and productive naval shipbuilding industry, which will be the foundation for Australia's future naval growth throughout this century. Although when delivered, the ships clearly met expectations, the problems with the Hobart class's construction revealed just how brittle and dysfunctional Australia's naval industry was. The sustainability of the shipbuilding industry is a key element in the procurement decisions of all major naval powers, and the lack of an integrated naval shipbuilding strategy led to stagnation and skills shortage in the Australian shipyards. Organisations like the ASC in Adelaide would have a decade of work followed by the Valley of Death, a period of time before the next generation of vessels were required by government, leading to an unsustainable national naval industry. Shocked into action by the problems encountered with the Hobart class, the government is now taking a much longer view in terms of naval procurement. Released in May 2017, the National Shipbuilding Plan is a commitment by the Commonwealth Government to invest in and sustain a truly capable sovereign naval industry able to produce Australia's major naval vessels indefinitely. This plan is based on a $90 billion investment in new ships and submarines and a $1 billion expansion to the ASC shipyard in Adelaide. With the increase of the submarine fleet to 12 and the production of the offshore patrol vessel, the fleet is now large enough to sustain a continuous naval shipbuilding plan. The end of the production of one class will then be immediately followed by the initiation of another. For example, once the last of the 9-ship Hunter-class frigates are delivered, ASC will begin construction of the Hobart class's replacement. The same process will occur with submarine production. Each new boat will be delivered on a 2-year drumbeat, allowing enough time to begin construction on the Attack class's replacement once the final boat is delivered. The development of a truly sustainable sovereign naval industry, one that can design, manufacture and sustain Australia's naval assets independently will be the foundation of Australia's growing naval power throughout the 21st century. Arguably, this may be the Hobart-class's most important legacy. The Hobart-class destroyers are now the core of the RAN's surface warfighting capability. They are the shield of the fleet, protecting assets such as the Canberra-class LHD from the deadly anti-ship missile threat, allowing for the deployment of Australian naval power into even a high-threat environment. When integrated into a network, their battle management system will substantially increase the effectiveness of the Anzac-class frigate, and through cooperative engagement capability will be able to engage airborne targets well over the radar horizon. Underwater, their integrated sonar systems, including the towed array, will provide the RAN with a highly capable ASW sonar suite, which is a critical capability until the Hunter class are in service. Although delivered several years late and several $1 billion over budget, the Hobart class will likely be forming the foundation of RAN task force operations until 2050. Their advanced sensors, weapons and combat system will ensure that no matter the threat, HMAS Hobart, HMAS Sydney and HMAS Brisbane will keep the men and women of the ADF safe wherever they are on the world's oceans.